Hello, my dear children. Today we are going to discuss the concepts or points in exercise 5.3 in the chapter continuity and differentiability. In the exercise 5.3, we are going to learn, we are going to discuss these concepts or points. Are you ready to learn these concepts well, my dear children? Right. First point, derivatives of implicit functions. Okay, my dear children, this is the first point we are going to discuss. And the second point is derivatives of inverse trigonometric functions. In first year, you have already learned the derivatives of trigonometric functions. Now, in this exercise, we are going to find derivatives of inverse trigonometric functions. Are you ready to listen, my dear children? Are you ready to learn well, my dear children? Right. Now come to the first point, derivatives of implicit functions. Before going to find, before going to discuss the derivatives of implicit functions, let us discuss these 2 points. What is meant by implicit functions? What is the definition of an implicit function? And what is the definition of an explicit function? We have to know the difference between implicit function and explicit function. Suppose the relation between the variables x and y, the relation between the variables x and y is given in the form of an equation like this: f of x comma y is equal to 0. The relation between x and y is given in the form of an equation like this: f of x comma y is equal to 0. For example, x minus y minus pi is equal to 0. This is a relation between x and y. In LHS, the relation between x and y is given like this: x minus y minus pi is equal to 0. Similarly, the relation between x and y is given in the form of an equation like this: x plus sin xy minus y is equal to 0. This is another equation. If we observe the equation 1, if we observe the equation 1, from this equation we can write, we can solve this equation for y. We can solve this equation for y. For example, see this first equation. We can solve it. This implies we can write y is equal to x minus pi. So here we can solve this equation for y. It means here y is equal to, we wrote f of x. In RHS it is a function in x. Here we wrote y is equal to, the right side function is a function in x. Then in this case this function is said to be implicit function. If we can solve for y, and if we can write y is equal to f of x, we say that y is given as an explicit function. Here expressed, y is expressed in the form of f of x, so it is called explicit function. In this first equation, we take this first equation, x minus y minus pi is equal to 0. In this equation we can write y value in terms of x. We wrote y value in terms of x, or we have solved this equation for y. We got this one. This value is a function in x. So y is equal to f of x. So if a function y is equal to f of x, we can write this equation like this, then the function is said to be explicit function. Okay, my dear children, what is meant by an explicit function? Now let us take the second example. What is the second equation? What is the second example here? X plus sin xy, x plus sin xy minus y is equal to 0. This is another equation. This is another equation. I have taken second equation. If you observe this equation, we can't solve for y. We can't solve for y. Means we can't write y value in terms of x from this equation. We can't find the value of y in terms of x, as in the case of equation 1 we have solved y, we have found the value of y in terms of x, but here we can't find the value of y in terms of x. So in this case, the function is said to be, this function is said to be an implicit function. An implicit function. Understood the difference between implicit function and explicit function, my dear children? Right. It means when the relationship between x and y is expressed in a way that it is easy to solve for y, and we can write y is equal to f of x. In the first equation we wrote y is equal to f of x. Then we say that y is given as an explicit function. Whereas in the second case, in the second equation, here it is not possible. It is not possible to write the value of y in terms of x. So in the second case, we say that it is an implicit, that y is a function of x, y is a function of x, and we say that the relationship of the second type, the second equation, is a implicit function. Okay, my dear children, understood the difference between explicit function and implicit function? Right. Now come to the second point, that is derivatives of inverse trigonometric functions. Here I am giving that formulas. After that I will prove first formula. We can follow the same procedure to get the remaining formulas also. Okay, my dear children, see here, first one, d by dx of sin inverse x is equal to 1 by root of 1 minus x square. This is the formula. D by dx of sin inverse x is equal to 1 by root of 1 minus x square. Similarly, second formula, d by dx of cos inverse x, derivative of cos inverse x, is equal to minus 1 by square root of 1 minus x square. D by dx of cos inverse x is equal to minus 1 by square root of 1 minus x square. Similarly, third one, derivative of tan inverse x. D by dx of tan inverse x is equal to 1 by 1 plus x square. D by dx of tan inverse x is equal to 1 by 1 plus x square. This is a formula for derivative of tan inverse x. Similarly, fourth one, d by dx of cot inverse x. D by dx of cot inverse x is equal to minus 1 by 1 plus x square. Minus 1 by 1 plus x square. D by dx of cot inverse x is equal to minus 1 by 1 plus x square. Remember these formulas, my dear children. These are very, very important formulas. These are very useful formulas for the upcoming exercise as well as for upcoming chapters. Similarly, d by dx of secant inverse x. D by dx of secant inverse x is equal to 1 by mod x. 1 by mod x into square root of x square minus 1. I repeat the formula. d by dx of secant inverse x is equal to 1 by mod x into square root of x square minus 1. Okay, my dear children, remember these formulas. Memorize these formulas well, my dear children. Right. Now come to the sixth formula, last formula. D by dx of cosecant inverse x. D by dx of cosecant inverse x is equal to minus 1 by mod x into square root of x square minus 1. Minus 1 by mod x into square root of x square minus 1. I repeat the formula. D by dx of cosecant inverse x is equal to minus 1 by mod x into root of x square minus 1. Remember these formulas. Learn these formulas well. Memorize these formulas well, my dear children. I told you I will prove the first formula, the derivative of sin inverse x. To prove d by dx of sin inverse x is equal to 1 by root of 1 minus x square. Previously I told you this is the formula. Derivative of sin inverse x. D by dx of sin inverse x is equal to 1 by root of 1 minus x square. Now we prove this formula. You follow the remaining to prove the remaining formulas. You follow the same steps. Okay, my dear children. So let y is equal to sin inverse x. Let y is equal to sin inverse. Let us consider this function is y. So let y is equal to sin inverse x. By implies we can write this equation as sin y is equal to x. You have learned this concept in the inverse trigonometric functions. If a function is given in the inverse trigonometric functions, we convert into trigonometric functions like this. Understood this step, my dear children? Right. So we take this equation, sin y is equal to x. Sin y is equal to x. We took that equation. Now differentiating with respect to x. Previously I told you this is a short form of the sentence differentiating with respect to x. Then what is the differential operator? D by dx. I told this point also many times. Here differential operator is d by dx. So d by dx of sin y is equal to d by dx of x. Here I wrote the differential operator on both sides. Understood this step, my dear children? Right. This implies here d by dx of sin y, not sin x, not d by dx of sin x here. Observe this function, my dear children. This is the function in y, not in x, but we are differentiating with respect to x. So here we have to use chain rule. Means we have to imagine this y as x in your mind. So d by dx of sin x, d by dx of sin x formula. What is the formula? Cos x. So cos y means x. We assumed in your mind. We assumed y as x in your mind. Okay, my dear children. So d by dx of sin x formula cos x. Okay, my dear children. Into d by dx of what you have assumed as x here, y. So d by dx of y. This is called chain rule. Understood this part, my dear children? In LHS, that is equal to d by dx of x. This is also direct formula 1. D by dx of x is equal to 1. Understood this step, my dear children? Right. Because here d by dx of sin x is equal to cos x. We use this formula here in the chain rule. We used this formula d by dx of sin x is equal to cos x, and we used the chain rule also. Understood, my dear children? Right. So here we got cos y into d by dx of y is equal to 1. So this continuation, cos y into d by dx of y. What do you write here? dy by dx. D by dx of y is equal to dy by dx is equal to 1. Understood this step, my dear children? Right. From this equation, we are finding the value of dy by dx. So we are sending cos y to RHS. This implies dy by dx is equal to 1 by cos y. Understood this step, my dear children? Right. This implies dy by dx is equal to 1 by cos y can be written as square root of 1 minus sin square y, because this is the trigonometric identity. Cos a is equal to square root of 1 minus sin square a. We used this trigonometric identity here. Understood, my dear children? Right. This implies dy by dx is equal to 1 by root of 1 minus x square, because sin y is equal to x. At the beginning of this question, we assumed sin y is equal to x. Y is equal to sin inverse x, by implies sin y is equal to x. So this is the derivative of the sin inverse x. Therefore, d by dx of y means sin inverse x. d by dx of sin inverse x is equal to 1 by root of 1 minus x square. This is the inverse trigonometric functions derivative formula. Remember these formulas, derivatives of inverse trigonometric functions. Okay, my dear children, you should memorize well. I am not proving the remaining formulas. You follow the same steps, then you get the remaining formulas also. Understood, my dear children? Right. Hello, my dear children. Now we start exercise 5.3 sums. The concepts of exercise 5.3 sums were over. Okay, my dear children. See question number 1. Question number 1. Not question number 3. Question number 3. 169 page. 169 page. Question number 3. I am not explaining question number 1 and 2. You follow these steps to find dy by dx for question number 1 and 2. Okay, my dear children? Because this is somewhat difficult compared to question number 1 and question number 2. That is why I am explaining the solution to this question number 3, not question number 1. Understood, my dear children? This is question number 3. Find dy by dx if ax plus by square is equal to cos y. This is the given equation. From this equation, we have to find dy by dx. Okay, my dear children? So, come to the solution part. I wrote the given equation as it is. Ax plus by square is equal to cos y. So, differentiating with respect to x. Differentiating with respect to x. This is the short form of that sentence. Differentiating with respect to x. In that case, what is the differential operator? D by dx. I told you many times. If you are differentiating any function with respect to x, then its differential operator is d by dx. So I am writing d by dx on both sides. Here d by dx, here also d by dx. So d by dx of ax plus by square is equal to d by dx of cos y. Understood this step, my dear children? I wrote the differential operator on both sides. Is it clear this step, my dear children? Right. Now this implies here two terms are there. So we can find the derivatives of the terms separately. So d by dx of ax, first term is ax. So d by dx of ax plus d by dx of by square. Second term is d by dx of by square. That is the second term. We are finding the derivatives of the two terms separately. Understood this part, my dear children? Right. Is equal to, come to RHS part. Here d by dx of cos y. We know d by dx of cos x formula, but we don't know d by dx of cos y directly. So it's a formula. D by dx of cos y. What is the formula? D by dx of cos y means minus sin x. So minus sin x. Here we assume that this y in your mind as x. So d by dx of cos x minus sin x. Understood this part, my dear children? Into d by dx of y, because we assumed this y as x in your mind. We are using here chain rule, by chain rule. Understood this RHS part, my dear children? Right. Now, a into here numerical coefficient, a is a numerical coefficient, so we can write it outside the differential operator. A into d by dx of x, d by dx of x, plus b into, here b is a numerical coefficient, we can write it outside the differential operator, so b into d by dx of y square. Understood this part, my dear children, in LHS? Right, is equal to minus sin y into d by dx of y. What is the d by dx of y? dy by dx, because d by dx of y means dy by dx. Understood this part in RHS, my dear children? Right. Now, come to the next step. A into d by dx of x. What is the value of d by dx of x? 1. Plus b into d by dx of y square. Here also we have to use chain rule, because this function is in y, but we are differentiating with respect to x. So we assume this one as x. It is in the form of d by dx of x power n. What is the formula? D by dx of x power n. N into x power n minus 1. We use this formula. So we get here 2y. By applying this formula, we get 2y into d by dx of y, because we assumed this y as x in your mind. Here also we used chain rule. Understood this part, my dear children? Right. Is equal to minus sin y into dy by dx. We wrote RHS part as it is. Understood this step, my dear children? Right. Okay, my dear children, we got this step. From this step, we write like this. That implies, what you get? A into 1, first term, a only. Okay, my dear children? Plus b into 2y. This can be written as 2by. Understood, my dear children? Into d by dx of y means dy by dx. Previously I wrote d by dx of y means dy by dx. So the second term can be written as 2by dy by dx. Understood, my dear children? Right. Is equal to minus sin y dy by dx. Okay, my dear children? Understood this step, my dear children? Right. Now we have to find the value of dy by dx. So I am writing all the terms which are having dy by dx. The terms which are having dy by dx. This term is having dy by dx. In RH also this term is also having dy by dx. So I am writing this term to LHS. I am bringing this term to LHS, and I am sending this term to RHS, because there is no dy by dx. So do by 2by dy by dx, it becomes plus sin y dy by dx is equal to minus a. Understood this step, my dear children? Just we rearranged the terms in the equation, then we get this step. Okay, my dear children? Right. From these two terms, we are taking out the common factor. What is the common factor here? dy by dx is the common factor. So by taking out this common factor dy by dx, here we get 2by plus here we get sin y. So 2by plus sin y into dy by dx. Understood this step, my dear children? Is equal to minus a. Understood this step, my dear children? Right. So dy by dx is equal to, we are sending this term to RHS. So minus a whole divided by 2by plus sin y. So this is the value of dy by dx. From the given equation, we got here dy by dx. Understood, my dear children? Right.